The question becomes, how do we find an expected value of a continuous distribution? When it was discrete, you remember we drew up our table of values and we went x times the probability of x. Of course, as we've now seen with continuous variables, you can't find the probability of an individual score, but we can still sum them up using integration. And so our formula becomes this for expected value. It's now the integral from minus infinity to infinity of that x times the probability of x, but that is now our probability function fx there. And a reminder that expected value is the same as the mean of the data. So we're going to model quarterly salary measured in thousands of dollars paid to salespeople by this probability density function. We're going to look at the median and the mean and then just give a description of the distribution. So the median, we go from minus infinity to m, and that should equal a half because it'll capture half of the data. So the probability would be a half. A little bit of an integration, and we solve that. There's our median quarterly salary, $21,112. But now to find the mean, we'll integrate x times x to the minus 7 on 2, and we'll go from 16 to, well, infinity. But remember, we're not actually substituting infinity in, we're saying what's the limit as x approaches infinity. X to the power of a negative power coming down, that's going to approach 0. 26.667, in other words, 26,667. So what does this tell us about our distribution? Well, the median is less than the mean, so therefore our data is positively skewed. More of the data is on the left-hand side than on the right-hand side. But the other statistical information we like is variance. How do we work that one out? We still have our same formula. The variance is the expected value of x squared minus the expected value of x squared. But in order to find the expected value of x squared, now it'll be the integral of x squared times function x. Let's find the standard deviation of that, of the sales. And now we're multiplying it by x squared, but we're taking away the mean squared, and we just worked that out. I've written it as a fraction there, it was 80 on 3. But to find the standard deviation, it's the square root of the variance. So I find the square root of that answer and we get 23,851. That is what the distribution looks like. And that's kind of typical in big companies. You see most of the people getting the salaries below the mean, and then a few up the top, your CEOs and what have you, getting quite large salaries. And that's why we end up having a median to the left of the mean. Quite normal in companies. As that standard deviation gets smaller, what we should be seeing is the data getting more clustered around the mean. Okay.